What we've been doing, this is kind of an evolutionary process. I'm actually in the middle of writing a book called The Art of Data Management. And because I feel that we've sort of lost that capability. If you kind of go back to the mainframe days and early days of open systems, managing data was a top priority, and through the early 2000s we sort of lost that skill set to some extent. And I think now with what's going on in the data center, we've got to get that skill set back in place. And the good news is that we have such good technology that getting that skill set back and managing data is actually a lot easier than it used to be. So how do I start? So let me say it this way. So some of you guys are so old you probably have forgotten who I am, and that would be me too. And then for those who don't know me, I ran a large storage integrator called SANS. Actually had several different names in its genesis. As part of that process, I kept changing my role and kept kind of moving up in the organization. Eventually, toward the end, I was running sales and engineering. I'll never forget, you got to be always careful what you tell your wife. It's like you'll get a lot of free tips today too, by the way. I remember, so we got this new CEO in. I don't know if any guys who were SANS guys remember it. And my wife goes, "Well, are you worried?" And I said, "No, I'm like, I'm the last guy that they're gonna, he's gonna like just give the whole company to me, I think." And so I go into the meeting, that's my attitude. And he starts a conversation off, "Well, we're gonna let you go." Like let me go to lunch, or what do you mean, let me go? And he goes, and I said, "Wait, you're firing me?" And he said, "Yeah." I said, "Well, I've never been fired before. Huh, feels kind of weird. Why?" He goes, "Well, you're not compatible with our vision." I said, "Oh, well, what's the vision?" And he said, "Well, we don't know." I said, "So no matter what the vision is, I'm not compatible with it." He goes, "Yeah." I said, "Awesome, that's great." So anyways, then there was a long story about severance pay that I won't get into. But so I started Storage Switzerland. I'd love to tell you that I had this grand scheme that 11 years from now we'd be this analyst firm and all this kind of stuff. Really, I just had to pay the electric bill. It was April in Houston, and you guys know in April in Houston that keeping the electric turned on becomes a top priority, right? So that was the thing there. Go ahead. So let's talk about sort of what we were assigned to go after today. And if you look at data, there's three essential problems that are really plaguing the data center as a whole. Obviously, number one is data. You don't need another statistic on data is growing. You're either experiencing it or seeing it. You know, what is different, and I think where we're missing it, is you don't realize just how bad this thing is going to get. We are really at the beginning of the growth, right? It's going to get exponentially worse over the next 5 to 6 years. I guess I need to face the camera more. Hang on a second. Let me go over here. So yeah, let's go back up. So about me. Now, so that's the real challenge with data. It's not that it's growing. I don't think that's a big shock to anybody. It's the rate it's going to grow and the rate it's going to continue to grow over the next 5 to 10 years, right? And I don't really see any end in sight. But you think about it. How many people are wearing an Apple Watch right now? Did you know 10 years ago that you needed to know your heart rate every minute of every day? How did we survive without that? Right? And now it's all being stored somewhere, right? Even people that don't like Apple are wearing Apple Watches, right? So it's just kind of a weird situation. I told my family that we were switching to Chromebooks a while ago, and the one requirement was that I stayed on iOS, or I was not allowed to be part of the family, right? So, and I weighed my options, and you know. The other challenge you'll see is users. Users are crazy now. Right? They used to just be a pain. Now they're just freaking insane. Okay? And generally you should not negotiate with insane people, but they kind of write the checks and pay the bills. So what are we seeing with users? We're seeing incredibly high expectations. I was at a meeting with a CIO of a large financial institution a few months ago. We were having this conversation, and this person walks in. I really don't know what their title was. And he goes, "I can't believe the blah, blah, blah is going to be down." It was their Oracle ERP application. It had some name for it. And he goes, "Yeah, we have to do this upgrade, and we have to do this, that, and the other thing. And it'll be about 15 to 20 minutes, assuming everything goes right." And the guy was just, I can't, we just can't do that. And he goes, "Well, we did this." And he goes, "Well, hang on, we sent you a memo 2 months ago letting you know this was going to happen. I followed up. You were in the meeting when we went through it. You didn't say anything. And now why are you complaining?" Well, because Facebook's never down. Right, so the guy, and they weren't that big, the guy's being compared to Facebook, which, by the way, is down, but the guy just happened to never be logged in at the right time. And so we see these sort of expectations nowadays. The cloud, in some ways, has actually hurt us because now users think that these things never go down, or they quickly forget them when they are down. And then the last thing, which is really interesting, is regulations. Right now, regulations aren't anything new. What is new is things like GDPR. Right now, GDPR, the General Data Protection Regulation, is a European Union thing. When you found a company named Storage Switzerland, all of a sudden you start doing a lot of business in Europe, which is kind of weird. And the funny thing is I've actually never been to Switzerland, and I'm trying to hold on to that. But what's interesting with GDPR is if you read the regulation, there's nothing in there that I, as an IT analyst, go, well, that's just crazy. And I love to tell the government they're crazy. There's really nothing, especially the European government, but there's really nothing in there that makes me go, well, that's just crazy. Right? If you look at it, it's actually kind of good practices, and in many cases, it's a pretty low bar. The only thing that I would say is crazy in there is the fines. They're going to be able to fine European companies up to 5% of revenue. I mean, you could be talking about millions, if not billions of dollars in fines. It'd be interesting to see how that goes. I can't wait. Gives me something to write about. But the challenge is now that this is getting very, very serious. There's aspects, for example, and what will happen is, I know this feels like a European thing, but first of all, if you do any business in Europe, you're in it, right? Secondly, we're not far behind, right? You're kidding yourselves if you don't think we're going to see the exact same thing or something similar over here. We just can't have people being as cavalier about data as they have been thus far, okay? There is some interesting things in here that really kind of impact the data management thing. I could do like 3 hours on this topic, by the way, but I won't, so just don't leave yet. One thing is, have you heard of this phrase, the right to be forgotten? Right? Anybody that's a husband would love to have that, like, can we just forget that I said that? So the right to be forgotten is if, let's say you're providing a cloud service of some sort, I as a user decide I don't want to do business with you anymore, I have now the right under this regulation to say, remove all my stuff. Okay? And it says all. Right? So that does not mean just delete all the stuff off of primary storage. That also means remove everything from a backup. How many backup guys I got in the house? Think about that. You need to remove one user's set of files from every single backup job you ever executed. Good luck. I don't know how you do it without destroying all your backups, right? That becomes a serious, serious challenge. Even in more modern backups where we're basically doing image type of backups, I don't know how you extract, so let's say you've been backing up a VM that has this user's files on it, and you have 100 copies of that VM. How do you go into that VM, all 100 copies of that VM, and delete just that subset of files? Because, by the way, you have other laws that say you need to keep X number of copies of that VM. Right, so now we run into this really weird situation. And so all of a sudden now we got to really think differently of how we manage data, how we protect data, things like that. So go ahead. So the other thing I realize is I tend to get to speak a lot where people have very sharp objects, knives, steak knives, or at right before sporting events, which is unbelievably not awesome. What I've learned is I don't have a lot of slides with a lot of words on it, so if you were hoping for a copy of the deck, I'd be glad to give it to you. It'd be absolutely no use to you, but we do have video. So you're going to see these three pictures very well. I spent a lot of money on these. I think they're about 50 cents each, so if you don't like the quality of the picture, that's really your problem, not mine. But I like to keep things real simple. There's essentially three types of storage. You got primary storage, you got protection storage, and you got retention storage. What is that storage has changed over the years, right? 20 years ago, retention storage was all tape, right? Protection storage was all tape. Primary storage was all hard drives. I remember the first time we implemented a SAN at SANS for a customer, and he needed a terabyte of storage. And I thought to myself, who needs a terabyte of storage, right? So things have changed there. Right now, kind of fast forward to the modern era, right? Primary storage is some flavor of flash, either all flash or hybrid flash. And then we're seeing that adoption continue to take place. Protection storage certainly is disk, at least at the front end at this point, and retention storage is increasingly becoming disk, very frequently object storage. So those three will be the pillars that we use to build things. Go ahead. So all the way over in the far left there, we got primary storage, right? What's its purpose? Its purpose is to rapidly deliver information and answers to people. That's it, okay? It really has no other purpose. Today it's all typically all flash or hybrid. I would say that for about 95% of the data centers that I visit, a low-end all-flash array decimates all of their performance problems, right? It cracks me up when I talk to yet another vendor who says, oh, we have a new storage system and it now can, because now we got all the NVMe drives coming out and everything, and so I'm getting another round of performance testing, and so now they have low-end systems that can deliver 700,000 IOPS. Okay, most data centers in total can't generate more than 50,000 IOPS. Whoops. We do a lot of writing on our site. By the way, the site is storageswiss.com. I wrote an article about 3 years ago, I think now, called What Are IOPS? It is still today the #1 article on the site. It's never #1, but in total, it's always #1. It's like number 3 or 4 every single day. Okay, so what that tells you, if you're trying to convey IOPS to people, if you're a reseller here or a channel partner, and you're talking about 800,000 IOPS, I got some bad news for you. They don't even know what 1 is. Okay, so just move on. Just say it's really, really fast, dude, and you'll be fine. So now, what's interesting, though, is primary storage still needs some help. So go ahead. And so what we've seen is sort of this, what I call HA storage. Right? So it's not really a second tier of storage. It's typically production class. And it might be, if the primary storage system is a all-flash system, it might be a hybrid array. If the primary storage system is a hybrid array, this might still be a hard disk-based system. Go ahead, hit it again. We feed this HA storage typically through some sort of a replication process. It could be a built-in replication process on the storage system itself, or it could be a standalone software application that feeds it as well. Either way is fine by me. This was something that we were recommending a lot about 3 years ago. I wanted the ability that if something went wrong with storage system A, I could tap right into storage system B and keep right on going. Obviously, we're not talking about a lot about disaster recovery today, but we would make another copy off-site. Go ahead again. Now, the other one, you notice that from the first picture, protection storage has grown a little bit. Protection storage typically tends to be about 5 to 10 times the size of primary storage, and that multiple is growing over time. If you factor in the fact that primary storage is growing over time, you won't have data centers big enough to hold protection storage soon. Okay? The cost of storage may be cheap. The cost of concrete is really, really expensive. Right? So being able to manage that and control that growth is really critical. Now, what we're seeing here is the first wave of protection storage systems that were essentially scale-up or single-box solutions, they are starting to hit the wall. Right? It is not uncommon for me to walk into a data center, and I'm just going to pick on Data Domain because they're not here, and see 20 to 30 Data Domain heads. Right? That's not what we were looking for. Right? And so that really becomes a challenge as you start to scale this environment. The other thing is, if you look at the primary storage and HA storage, the process of updating was relatively straightforward. Updating this, go ahead and hit the slide, becomes very, very difficult in the current data center. So we have, the fact that backup works at all to me is a miracle, right? Because we touch every single system with a variety of software applications, sometimes feeding one storage system, but typically feeding all these different storage systems. The fact that people can recover ever is amazing to me, right? one of the things that I do a lot of work on is disaster recovery planning now. And what I typically find, even in Fortune 500 companies and even in the low end of that, is that most real disaster recovery plans are just this, we're going to just do the best we can. Flood hits, not that it would ever flood here, and you just scramble, right? This guy's going to restore this thing. I literally had, when Harvey was happening, I had a guy call me and say, hey, I need some help recovering. I said, okay, great, where are you? I'm in my car. Okay, well, where are you going? He goes, I don't know. Okay, well, where's your data center? Oh, we can't get to it. I said, okay, so where are you going to recover at? I don't know. Well, you can't come to my house. So what are you going to do? I said, well, where's your data? He goes, into my back seat. Seriously? Okay, is somebody joking with me now, right? But that's what we see a lot, is there's sort of this scramble. And what we actually see a lot of times in protection is actually overprotection. The guys are running traditional net backup, net worker backup. There's some replication to happen. The database guys are making copies, and we're doing 1,000 snapshots because we don't have any limitations on the amount of snapshots we can do. And so the problem is nobody knows which one is the right copy of data, right? And so historically, you always pull the wrong copy of data. So that becomes a problem. So the fact that all this works at all is amazing to me. Go ahead and hit it again. And then we've got my friends all the way over here in retention storage, and if you look really hard, you can see it like isn't there. It's a ghost because nobody does it, right? Hit it again. What happens is what most people are using for retention storage is this thing, okay? And hit it again. What really happens is most people's retention storage is primary storage, right? I have yet to see, unless we actually did the architecture, I have yet to see an all-flash array not have 80% of its data not active. That means you're paying extra for data to sit there, but it sits there really, really fast, right? When all-flash arrays first came to market, I wrote blog after blog about, oh, be careful, because it wears out. It wears out. It'll wear out. It's going to wear out. Be careful. Oh, and I just want to write another blog. It's going to wear out. Be careful. It's going to crash. In fact, I wrote a piece that said how cool it was the way an all-flash array will wear out, because it's going to all wear out and you'll know it's going to happen on like a hard drive. None of that happened. Why? Well, how does a flash device wear out? When you write to it. If 80% of the data never moves, that's why you're not wearing them out. It's not because the flash technology got all that good. We just forgot that people weren't going to move stuff, right? So now we have these flash arrays that are fine. All that stuff was wrong, right? It was right, it was just wrong. And so now you've got this really weird thing that the two things that are the most expensive in the data center that are growing the fastest are also the most expensive, right? That's like totally wrong. The other challenge you have here is this protection storage is getting better and somewhat more expensive and becoming counted on more often. Because if you look at how we're feeding it today, we're asking things of protection storage we haven't asked of before, right? So we're able to boot from it, we're able to recover from it, things like that. And so now all of a sudden this becomes something to control as well. So what happens is we've got this 100% wrong, right? The things that are the most expensive in the data center are growing. And the thing that is least expensive, we don't use. It's a ghost, right? So what we've been working on busily is trying to help people fix that. So what we developed is a three storage system approach to this. So primary storage stays roughly the same. But now we feel that you can merge protection storage and HA storage. Okay? Remember, the role of HA storage was to give sort of zero failure. Well, the truth is most data centers really don't need zero failure for all their applications. Most of them don't need it for most of their applications. If there is actually an application that needs it, there's probably one or two, right? And that investment's probably already been made, frankly. It's probably some sort of a cluster or something like that. All the other applications, and by the way, we're seeing a massive increase in applications. I was at a large retailer based in Fort Worth, so you can kind of figure out who it is, who the company has more apps than they do employees. I don't know. I'm not in test dev. I don't get that at all. But I just nodded. I'm like, yeah, that's bad. But most of these apps can be down, right? The reason people say, well, my app can't go down, because they think they equate downtime to hours or days. If downtime was 5 minutes, 10 minutes, 15 minutes, and it worked every single time, and we as IT folks looked like we got it under control while this whole thing was happening, then you'd be okay, right? One of the challenges is we're sometimes our own worst enemy, in that when something crashes, it's like fire alarms and we're running all over the place, and we're, but if you go, oh yeah, I know what to do, click, boom, you're back up and running. That instills confidence, right? So why can we do this now? Well, there's a couple of things happening, right? Number one, the software that drives the process has just gotten better, right? We don't do full backups for the most part anymore. As I said before, we can launch volumes of data right from the protection appliance now. And so I don't need to transfer data anymore. And so the ability to recover, to take very, very frequent backups is easy almost now. And the ability to recover in minutes is also very doable. So that combination really changes things. And so now, number one, I eliminate a storage system, but I am counting on this protection storage to do more. So what changes here, and I'll just keep picking on data domain, is, everybody okay with that? You okay? Okay, just checking. So one of the things that we first tested a while back when products that came out that could do this sort of instant recovery type of capability was you launch the VM Datastore from a data domain box. Let's see, it's compressed, it's deduplicated, and it has really, really high capacity disks, and it wasn't really designed for random I/O. Performance was horrific, right? So all of a sudden, these things need to deliver some class of production performance, which is totally different than what we used to deal with in the past, right? The other thing is they still need to scale so that they can meet the capacity demands that are placed on it, as well as deliver performance. For me, in the protection class now, it's not as much about capacity, it's much more about what is the performance during recovery. So one of the things that we really instituted a lot in our disaster recovery workshops was concepts, and I'm sure you guys have heard a lot of these, like recovery point objective, recovery time objective. One of the things we added was called a RPE. And so what we would teach people in our disaster recovery classes is, look, you need to communicate what the recovery time objective is going to be, what the recovery point objective is going to be. So how much data am I going to lose? How quickly is it going to get back? And then we said, look, now you need to start communicating what the recovered performance expectation is going to be, right? Because you spoiled them and gave them an all-flash array. And so they think the whole world is 50,000 IOPS now. And you recover, and you recover them to a box, let's take again, sticking with data domain, that maybe could give them 1,000 IOPS, and they're mad, okay? We had a situation arise where we were designing a data protection solution for somebody. They bought a all-flash array, which I definitely won't say whose it was, and we took their old storage system, kind of like the reuse thing, I'm basically cheap, and we took their old storage system and made it the HA storage system, and we replicated data to it, and it was working great. And they did a firmware update to the brand new all-flash array. Did controller A, looked good. Did controller B, looked good. About like 10 minutes later, they both locked up. And if you know anything about storage, if you lose both controllers and it's a dual controller system, you got nothing, right, other than a recovery event. But it was cool because we had that HA storage in there. And so all they did was point all the applications back at the old array that had been the production array 6 months ago. The CIO literally got complaints about how bad performance was. One of them, so we were on site kind of working some stuff, one of them, the guy actually said in the kind of the debrief, you should have just not even bothered to recover. I said, let's grant his wish. boom, and unplug the box. But no, that's the advantage of being a consultant. You can say things like that. So it's a fascinating situation, right? So now being able to communicate, recover what the performance is going to be is really important, and making sure you can deliver some level of performance from that protection class storage is also really important. The other area, and I'll get into the cloud in a little bit, the other area where this becomes really important is in the cloud, right? There are some cloud providers, I don't know of any in Houston, but I've visited some cloud providers that are doing backup as a service, and they provide DRAS, disaster recovery as a service, and they have like 12 servers for that. Well, what happens if like a Hurricane Harvey thing happens and like the whole city declares? You're going to run the whole city on 12 servers? I mean, VMware's pretty cool and everything, but I ain't think of that's happening, right? So what those expectations are really becomes an issue. So that's really protection, storage. It's really being recast. What we're looking for is good performance, not necessarily flash performance, high scalability, and the other big thing, I kind of skimmed over it, I think it's time to move out of, and Rubrik's here obviously, so this is a little bit of a tip to them, but I think it's time to move out of having 1 billion different applications protect the environment and kind of centralize that down to one. It just makes life a lot easier. Next slide. HA storage still exists, so I'm not saying necessarily get rid of it. What I want to do is make it really, really small. So if there's one application, what our most current designs for that 1 or 2 applications, if that primary storage system's an all-flash array, that HA storage system's an all-flash array is just really small. All it has is just that application's data on it. Okay, next slide. Thank you, Warren, for being my clicker. That's awesome. I should just be able to go like that. That'd be cool. All right, so let's talk about retention storage. It's kind of a near and dear to my heart. We've kind of faded it in a little bit here. We're thinking about it. Go ahead, next slide. What we need to start doing is leverage retention storage. So what does retention storage look like? Why did it get such a bad reputation? Why does nobody archive? Right? We've been begging people to archive for as long as I've been in the business. Because remember, you're now paying a lot of money for 80% of this stuff that never changes. Right? That means you're backing it up 5 to 10 times on this thing, and it still hasn't changed. Right? Why can't you put it here? We did the comprising guys, don't get nervous. I'm going to save you here in a second. We did a project right when I started the company, and I did this whole thing, and I had graphs and the guy he had a storage tech tape library to show you how long ago that was. And I said, oh, dude, man, you got like 40 copies on tape, and all you need to do is put in an archive system, and we'll automate it, and we'll move it. And the guy goes, he's from Oklahoma. He goes, well, what if I just delete it all? Oh, sorry. What? Can I just delete it? Oh, well, but, well, no, you don't want, well, you said I have like 9 copies on tape. Yeah, I did say that. Well, because then you wouldn't need the retention storage because, yeah, it seems like that would save me a lot of money. Yep, okay. Well, like nobody ever says that. He goes, well, I'm going to try it. Really? He goes, yeah. So back then, they were about a 50 terabyte environment. So about 40 terabytes of it hadn't been accessed in more than 2 years. That day, they deleted all of it. I said, so we got to be friends because you're crazy and I like crazy people. So we followed them. I just checked with them end of last year. In the, let's call it 10 years since that happened, they've made 3 recalls from that data. Okay? Now, what's interesting is his concern now, though, is they're seeing an increase in need for that older data, right? So that becomes a little bit more of an issue. But it just puts it in perspective just how, if you wanted to go crazy, you could. Now, most people aren't going to go delete 40 terabytes of data, thank God. And so what we have to do is look at why this whole system has failed us thus far, okay? Part of the reason, and I'm going to get into tape in a little bit because I got a seed planted in the back, but part of the reason was tape, right? That I would go request data, and it would take a little while to get it back, right? In normal rational thought, if you haven't accessed something in 3 years, taking 5 to 10 to 20 minutes to get it back seems reasonable, right? Apparently not, right? Which is interesting because people will actually pay money for an SLA with Amazon and Microsoft in Azure and Glacier, and in the thing it says you're not getting it back for 2 to 3 hours. Well, that's weird. So I don't know what went wrong there. So then the second thing was, how do we get data to it? Right? So it's one thing to kind of measure it and say, oh, look, here's all this data. Great. Well, how do I get it to it? Right? And then the third problem was, the biggest fear for IT is, I know what's going to happen. The moment I move it, that's when those darn crazy users are going to want it back, which may or may not happen. Right? And so how do I get it back to them? And the other problem, quite frankly, is the archive guys, let's just call it that, were really victim of their own sales pitch, right? You can't walk into a busy IT professional's office and show an ROI that's like 37 seconds, right? Because here's what would happen. Let's say you had 100 terabytes of data, because I'm really bad at math. Last time I checked, 80% of 100 terabytes is 80 terabytes. You walk in and go, all right, you're paying $10 a gigabyte or a terabyte for storage over there. I'm $1 a terabyte for storage over here. If I take that 80 terabytes and move it here, I'm going to save you a ton of money. I'm so bad at math, I really can't figure out the rest of that. But it's going to be cheap, right? But before you do that, you got to buy the storage system that's 80 terabytes, right? You got to put the software in. I think the software is not free. You got to do all this work. And the real problem was, it may not be wise, but you've already paid for this, right? I have a friend of mine who bought a Volt, and I used to always laugh at him because he bought a Volt. Anybody on a Volt here? I just want to, okay, good, I can insult Volt owners. At the exact same time he bought a Volt, I bought a diesel truck, because I'm from Fort Worth, Texas, and just seemed wrong to buy an electric car in Fort Worth, Texas. So, and I get about, in my diesel, it's actually a diesel Jeep, it's actually a really nice car, 28 miles a gallon coming down here. And you know how diesel works, like the longer you run it, man, the better it gets. It just loves it. He got like 35 or something like that on his electric car, because it's, you know, part gas and everything. And he sold it. I don't do credit, but he bought it, he leased it. He broke his lease to get out of it because gas prices weren't going high enough, fast enough for him. I'm like, but you already own it. What? You understand the math isn't going to work here, man. And so anyways, it's sort of the same thing here. They already own, it may not be the best decision, but you already own the 100 terabytes, right? And also, I don't know of an IT professional in the world that's going to take 80 terabytes, come walking in with anything, and say, let's copy it, because that's fun, right? I don't know how long it takes to copy 80 terabytes across a 10 gig network anymore, but I'm thinking it's not fast, right? So that was part of the problem. So what we need is to kind of change the way we look at this stuff. So the first thing is, I recommend that people start as small as possible on the retention storage, right? So nowadays you can do a little 3-node system with probably about 100 terabytes of capacity, relatively affordable, and then start migrating data as you need it. But you don't migrate all of it once because you don't trust it yet, okay? What you do is you just sort of turn the dial. So you just get the system in place, start analyzing what's going on in the environment, and then when it comes time to buy your next storage system, right? Because why are you buying a storage system now? You have a system that probably, if it's an all-flash array, it's probably going to do, a bad one's going to do 100,000 IOPS. A good one's going to do 300,000 or 400,000 IOPS, so it's probably not performance, right? If it is, we have a special session for you. So it's probably capacity, right? Okay, well, instead of buying more capacity, that's when you turn the knob, all right? Now, we start filling this up. Next slide. And now this starts to get a little bit bigger, right? So we just slowly start dialing up. So in many cases, we'll see data that's 3, 4, 5, 6 years old on these arrays. Oh, that smells good. And instead of migrating it all, just migrate the oldest 5th year and realize that none of it ever gets touched. That's cool, right? Do it again. Now, over time, we start migrating more and more of it. Okay? What we want to get people to is start off migrating stuff that's 5 years old, then 4 years old, so on and so on. And then eventually I want you to start migrating stuff as soon as it hits the 90-day mark. Right? I want this thing to be as small as possible, but I don't want you to trust me or any vendor until it proves itself. And starting at 5-year-old data is a pretty safe place to go. Right? Now, look what happens. This is big, but, and I know my numbers are wrong as far as dollars, so guys don't skewer me. I'm paying $1 a terabyte here, not $10 a terabyte. I want this to grow. And by the way, this isn't really that good when it gets big. These get better as they get bigger, right? So that becomes another issue. The other thing you'll notice is look what happened to my protection storage. It shrunk too. Not because I want you to spend less money in data protection, I just want you to buy better stuff. Because now I want this protection storage to really, you notice the other thing that happened in this is the HA storage is gone. Right? So I want you to put more money here so I get a faster recovery effort and I can eventually maybe eliminate or at least narrow down to 1 or 2 applications the concept of HA storage. And now all of a sudden this becomes a very easy environment to manage. What happens is data comes in, it hits a 90-day, it's protected during that 90-day period of time, and then after 90 days it's moved over to this storage system, the retention storage system. Now here's what will happen though. Okay, once I get you to 90 days, all of a sudden access here is going to go up, right? If it's 5-year-old data, not going to touch 5-year-old data very often. But if it's 91-day-old data, I'm going to be hitting it, right? And so what has to happen now, so that 5-year-old data didn't matter, I don't know, well, it still mattered, but the recall time was probably less of an issue because it frankly probably wouldn't happen. Now, if it's 91-day-old data, it's going to happen. And so I need this to recover. So there's a term in the industry called active archive. And this is kind of what we're talking about here is we want this to be very, very active. In fact, I would say that if you've invested in this sort of retained system like something that, like, say, a Cloudian would have, and you're not accessing it, you're wasting your money. Right? So we actually, again, want to flip it around a little bit. We want to see stuff coming off of here as quickly as possible. The other key thing is what this now gives me. So let's go all the way back to GDPR, my European friends. If I've now got a policy that's, let's say, 1 year on my protection storage, and then I got decades here, and somebody says delete me, I'm only exposed to a year right here. Everything else over here is granular information. It's just file data. I just find them and remove them, right? And the other advantage here, so how do you prove something didn't happen that never happened? Right? You can't. So one of the problems with GDPR is they don't put any way to, so if I call up Amazon and say delete me in Germany, and they do it, how can they prove they did it? Because I don't exist, right? Here, what I can actually do is just change the encryption keys, which and is actually outlined in the regulation, and that is the equivalent of deleting you, right? And now I have something to show you that you've been forgotten. Because it actually doesn't say delete you, it says be forgotten. So if I just destroy the encryption key, I've done the exact same thing. The other big thing is 20 years ago, we used to preach a very similar message and tell people, you know, data's getting too old, you want to delete it. And if I give this sort of a presentation in New York, it always comes up. But there's this concept of I want to get rid of data after a certain period of time because I'm exposed, okay? I will tell you that if you're living under the misconception that you can do something bad and get away with it electronically nowadays, you're crazy, right? Because everything has a trail, and you know, I can't tell you how many lawsuits we've seen where the plaintiff had a copy of data emailed to their whatever account. So unless you're going to set a policy in your organization that there can be no emails outside of the company, which sort of defeats the purpose of email, you got a problem, right? The other challenge here is being able to find information, right? So as if you look at using these other platforms, one of the biggest generator of data today are cameras, right? The problem is, how do you find data that's in a video? Well, what's interesting is actually there's a lot of data within a video now, right? Automatically, if a camera can tell you where it was, what time it was, in many cases weather condition, what type of video was shot, all those sort of things. So it has this stuff that we call metadata. But most storage systems, certainly a primary all-flash array, has no idea how to track all that metadata. Right? Your typical operating system just can't do that. A object storage system, which is what we would use in retention storage, can absolutely track all that stuff automatically. Right? So how many people are Windows users? You're getting stakes, so you have to answer my questions. Okay. How many people are Mac users? How many people know that you've had the ability to add metadata tags to all of your files for years? How many people do it? Because humans are terrible at that stuff. I remember in our company, before I made everybody go to Chromebooks, which is a whole different story, we were all Macs, which is why we're all Chromebooks, because I'm cheap. And the operating, I forget which release it was, but OS X something, came out where we could put tags on top of files. And so in our world, we're all files, and so finding files becomes really important. So we even did a memo, which for my company is unusual because we don't ever do memos. We did a memo on how we're going to tag stuff. We were really disciplined. We're like, oh, we can't have 1 billion tags. We got to have like a certain amount. And yeah, we're all going to do it. And the first week we were tagging stuff. All the files were tagged, and I could go object. And I could see all the files on our server that had object, and it was awesome. And then everybody stopped because it got too hard. Because humans are terrible at that. Machines do it automatically, and they never complain. Right? So tracking that data becomes critical. And then finally, when we're dealing with the mass amount of data that we're talking about here, finding information becomes critical. It does you no good to keep data forever if you can't find it. Right? And going again back to GDPR, if somebody says, I want to be removed, and you can't find them, and somehow later they find out that you didn't actually do it, you got problems. Right? So next slide. About 5 minutes on the cloud. Is that right? I don't know, this cloud thing, I don't know, seems like a deal. So I haven't talked about it at all. And you have to manage data in the cloud just like you manage data on your data center. Right? The thinking, I guess, that IT will be replaced because of this cloud thing, I think it's long gone now. And you're going to need to manage the cloud just like you manage everything else. What's really important to understand, if you think about each of the cloud providers, first of all, the cloud is not like some magical place where unicorns live. It's just another data center. Right? It might be better run than the data centers you know of, but it's just a data center. And if you notice, each one of these providers now have multiple types of storage. Right? Now, Amazon has EBS for the EC2 support. They actually now have a faster version for a lot of the AI and machine learning stuff that's going on. They have S3, which is sort of the object store, and then they have Glacier, which is basically long-term, really, really cheap storage, but expensive to access. So they even follow the same practices, right? So where does it make sense to use that? Next slide. What you don't want is this. A primary storage system, and then everything in the cloud, right? Because the problem is, so when I travel, like I live in Fort Worth, right, and I own a car. It's my diesel Jeep. But when I go to San Jose to visit clients, I rent a car because I'm only going to be there for a little while. Actually, nowadays I just Uber everywhere because it's like even cheaper than rental, especially with California taxes. I would like to know, as a rental car customer, what a convenience tax is. Because there was nothing convenient about me paying extra for renting the car. I'm just saying. Why don't we just call it, we're taxing you to pay for our stadium tax, because that's what it is. And your 49ers aren't all that good anymore anyways, so just saying. But back to this. So the concept here is, with the cloud, you're renting, right? You never own what's in the cloud. You're renting it. So the cloud is very, very good at temporal things. It's not so hot at long-term permanent things. Data is long-term permanent. Another way to say it is data has gravity. The cloud is really good at compute, and compute is actually quite temporal, right? So what you want is to use the cloud for what it's best at. Now, there is some exceptions. If you have 5 terabytes of data or even 50 terabytes of data nowadays, it probably doesn't matter, and the cost to have all this stuff on-prem, yeah, you're probably better off in the cloud. But when we get into petabytes of storage especially, but even high terabytes, the ongoing cost of data in the cloud becomes quite expensive. And also, one of the big challenges the cloud providers have is understanding what their bills are telling you nowadays, right? Trying to figure out egress charges. And I had a customer show me their Amazon bill, and he said, "Can you explain this to me?" I handed it back to him. I said, "Nope, not my job." The next slide. What you really want is, well, I just hit all this. You're a rented version of the same problem. Next slide. So what you really want is this. I'm not saying don't use the cloud. I absolutely would not say that. What you want is a small version of it, okay? And what I want to be able to do with protection storage, again, remember with protection storage in my world, I've got you down to maybe 90 days. But if you're not as aggressive as I am, maybe a year. But a finite period of time now is on protection storage, okay? What I'm trying to do is get you to put that smaller amount in the cloud, but only have that smaller amount in the cloud. Because what I want to be able to do is leverage what the cloud is really good at, remember, is temporal use of assets. That's a disaster recovery site. The most expensive thing you'll ever do is equip and man a disaster recovery site. If I could just use those guys, it's great. And I'm pretty much guaranteed that I don't think Amazon's going to run out of compute capacity. And if they did, we probably have some other bigger problem. So I'm not worried about that either. The same thing with retention storage. Now, as this starts to scale, there's a couple ways you could look at this. If you're in that early stage like I talked about, you could use the cloud as sort of your DR copy, right, of your archive. As you really start to scale, you probably won't do that. But what you might want to do is be able to move data into the cloud and do stuff to it. Okay, so how you move that data all of a sudden becomes really important. So for example, one of the things that we do is we push our video content up to the cloud and have it automatically transcribed for us. That's pretty cool, right? There's the ability now to have video content pushed up there and analyze every single image and tell you how many people are smiling and how many people are frowning, right? So a lot of, I should say a lot, but a few retailers nowadays are using security camera as marketing assets, right? Because if you're walking out of the store mad, that might be indication that something went wrong, right? So the ability to temporarily push that data up there, process it, and then pull it right back becomes very, very valuable. The other thing we're starting to see in the cloud is the ability to, is that each of these providers are kind of getting good at different things. So Amazon might be good at one service, Azure might be good at another, and Google might be good at another, right? The only problem with Google is they never actually finish everything. It's always in beta. Let's see, took a stab at Google, got that out of the list. So the ability to leverage this cloud, but again, in an intelligent way. Understand, all we're doing is applying the same intelligence throughout, no matter what the next thing is, right? And so now I can scale according to what's going on. So we've got a lot of guys that are doing AI and machine learning stuff, and all of that is being temporarily pushed on the cloud, processed really, really hard, and then the results are pulled back, right? So it works fairly well. Next. So to wrap up, I think data management now is a critical skill. It's something that we have to do. Number one, it'll save you money. Number two, it'll improve your ability to survive a disaster. Right? Go back to that 100 terabyte example. What would you rather recover, 100 terabytes or 20? Right? But data protection has fundamentally changed. right? I think data protection now is one thing, and it does 99% of the recovery effort. We don't have different services for different applications. We have one thing. And then the last thing is performance is a commodity. We got the whole thing backwards. The value actually will be in secondary and tertiary tiers of storage. Performance, thanks to flash and then subsequent memory technologies, is actually the commodity. We're working with a very early stage startup who is probably years away from having a product in their lab on 5 SSDs on a $2,000 server. They got 350,000 IOPS. Primary storage is now $2,500. It has no features, by the way, but it is an early stage startup. So think about that as you start to kind of move forward. And flash is a temporary thing. The next evolution of memory is just going to get faster, right? So that's the investment actually should be in the backside, managing the protection process and then managing the data as itself. Yep.